everyone. In this lesson, I'll complete solving the ministerial question of continuity part 2. In the previous lesson, we reached number 18. Number 18, f of x equal to 3x power 2 minus x minus 2 over x minus 1 is discontinuous function at x equal 1. Which of the following function is redefined to be continuous function? To find the answer of this question, we need to find the limit of this function when x approach to 1. Limit 3x power 2 minus x minus 2 over x minus 1. If we substitute directly, the denominator will be 0. Then we will analyze the numerator by experiment. 2 bracket 3x x negative 1 plus 2 over x minus 1. 3x times x, 3x power 2, 3x times negative 1, negative 3x plus 2x, negative x, 2 times negative 1, negative 2. Reduce x minus 1 with x minus 1. Substitute every x with 1. 3 plus 2, 5. Then the right choice is C. Number 19. Which of the following function has removable discontinuity at x equal to? Removable discontinuity, it means which of the following function has limit when x approach to 2. As you see, this function, we cannot analyze the numerator because it is addition of 2 square. Then if we substitute with every x with 2 directly, the denominator will be 0. Then this function has no removable discontinuity at 2. For this function also, if we analyze the denominator difference of 2 square, then we have x minus 2, x plus 2. If we reduce x plus 2 with x plus 2, still we have x minus 2 in the denominator and 2 minus 2, 0. Therefore, this function also does not have removable discontinuity at 2. For this function, absolute value, we solved many functions of this kind. This function has limit of negative 1 when x approach to 2 from left and positive 1 when x approach to 2 from right. Therefore, this limit has no removable discontinuity when x equal 2. Let us check the last function. Limit x approach to 2, factorize by 3, x minus 4, factorize by 2 for the denominator, x minus 2 equal to limit x approach to 2. Here I have x square. Open this bracket difference of 2 square, x minus 2, x plus 2 over 2, x minus 2. Reduce x minus 2 with x minus 2. Substitute every x with 2. 2 plus 2, 4 times 3, 12 over 2 equals 6. Therefore, this function has limit when x approach to 2, and therefore it has removable discontinuity. The right choice is D. Question number 20. Which of the following function has removable discontinuity at x equal negative 3? For the first function, if we substitute negative 3 in the denominator, would be 0, undefined term. Therefore, this function has no removable discontinuity. For the second function, let us find the limit when x approach to negative 3. Analyze the numerator by difference of 2 square. Factorize the denominator by 2. reduce x plus with 3 with x plus 3, substitute every x with negative 3, the answer will be negative 6 over 2 equal to negative 3. Therefore, this function has removable discontinuity at negative 3. For this function, we cannot analyze the numerator because we have addition of 2 squared. And for the last one, if we substitute every x with negative 3, then we have the denominator 0 and undefined term. The right choice is B. Question number 21. Which of the following function is discontinuous at x equal 3? For the first function, it is a linear function, so it is continuous everywhere. So it is wrong choice. For the second function, 3 is within the domain of this function, so it is continuous when x equal 3 because the domain of this function is all real number except positive negative square root of 3. Let us check this function. F of 3 equal 5. Limit when x approach to 3. I substitute in this segment. The answer is negative 3 plus 2 equal negative 1. Since the value of the function at 3 not equal to the limit, then this function is discontinuous when x equals 3. It is the right choice. Question number 22. Which of the following has removable discontinuity at x equals 0 and non-removable discontinuity at x equals negative 1? Let us find the limit when x approaches to 0 for the first one and see if the discontinuity exists, if the continuity exists or no. X factorized by x for the denominator, x plus 5, x with x, then the answer is 1 over 5. So this function has a removable discontinuity at 0. But when x approaches to negative 5, then negative 5 plus 5, limit when x approaches to negative 5, it will be 1 over 0 and defined and has non-removable discontinuity at negative 5. So this choice is the right choice. Let us check the second one. When x approaches to 0, then this function has a removable discontinuity because the answer is 1 over negative 5. But when x approaches to negative 5, also the function has x minus 5, then the answer is 1 over negative 10, also has removable discontinuity. Therefore, this choice is wrong. For the third function, this function has no limit when x approaches to 0, since 5 over 0 square plus 0, it is 5 over 0, and it is undefined. So this function has no removable discontinuity at x equals 0. It is wrong choice. For the fourth one, also this function, if we substitute x equals 0, then 0 is not in the domain of this function, and this function has no removable discontinuity at 0. The right choice is A. Which of the following function, number 23, which of the following function has removable discontinuity at x equals negative 3? It means which function has a limit when x approaches to negative 3. For the first function, we cannot analyze the numerator because it's addition of 2 squares, so it is wrong, and the denominator will be 0 when we substitute every x with -3. For the second function, also, if we analyze the denominator addition of 2 cubes, then the result is x power 2 minus 3x plus 9 over x minus 3. I cannot reduce x minus 3 with x plus 3. If I substitute every x with -3, then -27 plus 27 is 0, and this function has no removable discontinuity at x equal -3. For the third function, if we analyze the numerator addition of 2 cubed, x plus 3, x power 2, reverse sign, the first time multiply the first term times the second term, 3x, plus quadratic of second term over x plus 3. Reduce x plus 3 with x plus 3, substitute every x with -3, the answer is -3 square 9 minus 3 times -3 plus 9 plus 9, 27. Then the limit exists, and this function has removable discontinuity when x equal -3. For the fourth function, if we substitute directly, the denominator will be 0, then it is wrong. The right choice is question number 24. Which of the following function has removable discontinuity at x equal 2 and non-removable discontinuity at x equal -2? For the first function, this function has no removable discontinuity at 2 and no non-removable discontinuity at x equal -2, since if we analyze the denominator difference of 2 square, then I cannot reduce any bracket from this. If I multiply by the conjugate of the numerator, x minus square root 2 times x plus square root 2 over x power 2 minus 4 times x plus square root 2, then x times x power 2 minus square root 2 times square root 2 over x power 2 minus 4 times x plus square root 2. Also, I cannot reduce any bracket, and if I substitute 2, the denominator will be 0. If I substitute -2 with any x, the denominator also will be 0, then this choice is wrong. For the second function, the limit when x approaches to 2, for this function, factorize the numerator by x minus 2, analyze the denominator difference of 2 square, x plus 2, if we substitute, reduce x -2 with x -2, substitute the denominator with 2, then 2 plus 2, 4, 2 over 4, 1 over half, the limit exists, and this function has a removable discontinuity at 2. But if we substitute every x with -2, -2 plus 2, the denominator will be 0, and this function has non-removable discontinuity at -2. Therefore, it is the right choice. For the third function, if we analyze the numerator by experiment, x plus 2, x minus 1 over x minus 2, x plus 2, reduce x plus 2 with x plus 2, then the denominator has no will be 0 if when x equal to 2, 2 minus 2 0, then this function has non-removable discontinuity and 2, then therefore it is wrong. For the third function, if we analyze the numerator addition of 2 cubed x power 2 minus 2x plus 4 over x plus 2 x minus 2 and reduce x plus 2 with x plus 2, also the denominator will be 0 if we substitute every x with 2, and therefore this function has no limit when x approaches to 2. The right choice is B. Question number 25. On which interval f of x equal 2 over square root 4 minus 2x has no point of discontinuity? No point discontinuity, it means the term inside the square root should be greater than 0. Therefore, solve this inequality to find the value of x, x 4 greater than 2x, 4 over 2 greater than x less than 2. X less than 2 means negative infinity to 2 open interval. The right choice is question number 28. F of x equal to square root 2x minus 1 over x is discontinuous over which interval? Discontinuous over which interval? It means we want to find the reverse of the domain of this function. The reverse, it means the term under the square root should be less than 0. This term is less than 0 if the numerator is positive and denominator is negative, or the reverse, the numerator is negative and the denominator is positive. Then we will solve both cases. 2x minus 1 greater than 0, x less than or equal 0 since x is in the denominator. This case gives me 2x, solve this inequality, greater than 1, then x greater than 1/2, and x less than or equal 0. The intersection of these two intervals, x greater than negative, x greater than 1/2, and x less than 0, it is 5. The second case, 2x minus 1 less than 0 and x greater than or equal 0. Then 2x less than 1 and x less than 1/2, x greater than or equal 0. The intersection of these two intervals, x less than 1/2, this is the points, x greater than 0, this is the point. Then the intersection is 0 to 1/2, close from 1/2, open from close from 0, open from 1/2. Choice B, since 1/2 is not within this interval. Question number 29. F of x equal negative 2 over square root x is discontinuous over which interval? Then I'll find the reverse of domain of this function. Yeah, it means x less than or equal 0 since it is in the denominator. X less than or equal 0, it means negative infinity to 0, open from negative infinity, close from 0. Choice D. Question number 30. F of x equal 1 over square root 3 minus x is discontinuous over which interval? Discontinuous over which interval? It means the reverse of the domain. The domain is when 3 minus x greater than 0. The reverse is square root 3 minus x less than or equal 0. It means 3 less than or equal x, or x greater than or equal 3. It is 3 to positive infinity, this interval. So is A. Question number 31. F of x equal 1 over 4x plus 12 is discontinuous over which interval? The reverse of the domain, 4x plus 12 less than or equal 0. Factorize by 4, x plus 3 less than or equal 0. It means x plus 3 divide both sides by 4 less than equal 0. X less than or equal negative 3. It is negative infinity to negative 3, close from negative 3, open from negative infinity. Choice B. Question number 32. F of x equal 1 over square root x minus 1 is discontinuous over which of the following interval? Discontinuous, it means I want to find the interval reverse of domain. The domain is x negative 1 greater than 0, and the reverse is x minus 1 less than or equal 0, since the root is in the denominator. That means x less than or equal 1, less than or equal 1, it is negative infinity to 1, close interval from 1, open from negative infinity. The right choice is D. Question number 33. F of x equal negative 1 over square root x plus 3 is discontinuous over which of the following interval? Set x plus 3 less than or equal 0, x less than or equal negative 3. It means negative infinity to negative 3, close from the side of negative 3, open from negative infinity. The choice is A. Question number 34. Which of the following is true? Limit f of x when x approach to c is L, then f of c is equal L. It is not necessary. This choice is wrong because maybe the limit not equal to the value of the function as the piecewise function. For example, x plus 2 when x greater than or equal 1, and 10 when x less than 1. Then the limit, not equal 1. Then f of 1 is 10, but the limit when x approach to 1 is 3. Limit negative absolute value x minus 4 over x minus 4 when x approach to 4 from left is 1. When x approach to 4 from left, the absolute value x minus 4 equal to negative x minus 4. Therefore, the value of this limit will be negative x minus 4 over x minus 4. X minus 4 with x minus 4, negative times negative, then the answer is 1. Therefore, this statement is true. Limit sine 2x over x equal to 2. It is wrong. This is true when x approaches to 0, but when x approaches to pi, it is sine 2 pi over pi. Therefore, this is wrong. Limit x approaches to 0, cosine 3x over 4x, it is not exist, since cosine 0, 3 times 0, 0, cosine 0 is 1, 1 over 4 times 0, 0, it is undefined term. Therefore, the right choice is B. Question number 35. F of x is continuous over which interval? Continuous, it means x negative 4 greater than 0 and not greater than or equal 0 because it is in the denominator. X greater than 4, it means 4 to positive infinity, open interval. B is the right choice. See you next lesson.